Hi friends, welcome back again with a new video lesson for our tutorial for PLC programming using ladder logic programming. Actually today I come with a new things which is BCD. So what's BCD? BCD is a binary coded decimal, and this is might be you have seen in different application but you didn't notice because it's a little bit like uh, confusing for people not working in the logic field, but actually it is there in every application. You can find it in every application showing you the numbers. All people knowing the number on the left, like the digit numbers like 0, 1, 2, 3, 4, 5, 6, and in our daily life every day we deal with the numbers in screens, and we can see the numbers in counter in everywhere we go, like in bank, everywhere you found numbers displayed to showing the counters of everything we deal with. So all numbers in our daily life displayed in um, decimal or in digits like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But actually uh, behind the numbers that you see in digits, there is a binary, which is the number or the language for computers. So computers and digital systems working with the binary, and people, normal people, can't recognize the binary format like hexadecimal or binary or octal, the number systems. So we need to talk today about this thing, how to convert the binary into a decimal, which is a BCD, and what is the application of PLC in this thing. It's an interesting topic, and for sure it is not like something additional. It is essential and existing everywhere. And in the couple minutes of our session, I need to let it come very simple to you, and to let you understand the historical migration for this BCD and how it was very hard in implementation and become very easy using PLC. So first of all, you can see in this table, you can see on the left, the first column, you can see the digits, and you can see for bits like A, B, C, D, and by 4 bits you can implement for sure 2 of power 4, which is like 16 values, and we need also for the decimal number or the digits from 0 to 9. Okay, so screen everywhere, you can see the screen like this. You have like, this is the 7 segment, what's so called the 7 segment, and you can see the 7 segment. It's nothing but like 7, because it's named 7 segment because it composed of like 7 lead, A, B, C, D, E, F, G, and based on eliminating which leads you can form any number. For example, to form the number 1, you need to eliminate only B and C and turn off all other 1. And for forming number 2, so you need A, B, G, E, D, and on, and C, F, off, and so on. You can form any number from 0 to 9 in this way. So how we doing this? We're doing this because by doing the what's so called encoding. So this is a digital number from 0 to 9, and this is a binary equivalent to 0, 1, 2, 3, 4, 5, and this is the encoding. Like I need to transfer this thing because if I need number 2, so this is the binary equivalent to number 2, and this is the equivalent in A, B, C, D. Like to have number 2, so we need A, B, and D, E, G on, and only F and C to be off. Same thing if I need the 8, you can see all are on. Okay, like this 8, all are on, all bits are on. So this is a very simplification of how the binary coded decimal happen, or how we form it logically. But you can imagine to form this table in the beginning of the era of digit system, we have to make a BCD to 7 segment by implementing a couple of logic gates like this in this form to by having the input, you can have the output for this decoder to see the status of each lead of the 7 leads that we have to form one number from 0 to 9. That's complicated for electronic people. It's now easy, but before it was like a very complication of logic calculation to implement such a decoder. But now after the digital system we have ICs. So this is the IC that we have, and in this IC we concerned with the inputs A, B, C, D, E, F, G, which is the 7 segment. And by having the input to this by having this is output from the this decoder. Once we have these values, we can apply this value to the 7 segment to form the number that we need. Okay, so now we have just a IC that work or functions as the decoder. But this is just introduction to what we're gonna do. But with PLC, things become easy. But as engineer and as people working in PLC programming, you should understand the background of what you do. So here, one example of the 7 segment. Actually, we have 2 7 segment for input and 2 for output. And as you can see, it's very simple. By connecting the inputs to this input and the output, same connecting directly each input connected to one output. So by getting the input, you can form any number at the display. So let's implement this very simple application. I spent some time to make the in this presentation to showing you how the BCD works, and back to make one application very simple in PLC to show you how it is very simple now. In your project, you just buy this 7 segment and you have your input outputs in your PLC and just implementing the simple program that we're gonna do to test our program. So simply here we will put our inputs here in the way like straightforward like this. Okay, let me add another rungs like this. Okay, so this one will be here, this one will be here. So I just here need another input, and for this guy I need input output, and that guy I need input output, and I need to add another rung. I need to have 7. 1 2 3 4 7 6 7 8. Okay, so we need to add this one also, input output. We need to have this also input output, very simple, and this one also input output. So now 1 2 3 4 5 6 7, we need another one, so adding additional rung to complete this thing. And let's put the input outputs. As you can see, this is output here, and it's input here, and this input here, it's output there. Okay, very simple guys to implement such application. Okay, and by having this one also, and this is the third one, and this is the third one, output and output, next output, input, I'm sorry, next output, next input. Okay, wait a moment guys, so this guy is not input output, so I need to add number 5 here, and number 6 here, and number 7, the last one. This is output for 7, output for 6, and out for 5, and for sure 7, 6, 5, and 4, something error. Let's see what's the problem. 1, 2, 3, 4, 5, 6, 7, 8. So this one is etc. So no need for this one. We need to delete that run. So now let's download our program and see if the logic work correctly or not. Then run and see what's going on. So let's start with the decimal one. So in decimal, I select the decimal and I'm trying to show 1, 2, 3. As you can see, the binary of number 3 is 1, 1. Okay, so the binary of number 4 is 0, 0, 4, and so on, guys. Like this is 5, 6, 7, which is 1, 1, 1. And same thing for 8, 0, 0, 0, 1, and so on. Let's start the hexadecimal. So hexadecimal is like same thing, but when we're reaching into 9, so 10 is A, B, C, D, and E and F, okay, which is 1, 1, 1, 1. We can add also the other digit for the other 7 segment until reaching to F, which is all on. Same thing, guys, we can see the hexadecimal format. So this is the hexadecimal format, and so on. As you can see, guys, it's very straightforward, and you can see the input connected to the output directly. So the programming even is very easy, and that's thanks to the technology that we have just the 7 segment and have the IC that by just wiring straightforward and just a simple program like this, we can implement every type of display. Like we can display the information in decimal, we can display the information in hexadecimal, we can display the information in hexadecimal like this. We can display whatever the way we need to do. To let scientific people can make a binary calculation, and also to help the regular people with the most majority to see their numbers and counters in the way they usually see numbers in decimal format. So this is our application for today for the PLC programming ladder logic for the BCD binary coded decimal. Thank you for joining us today so much, and I hope to see you very soon in a new application, a new project, and a new video in our series of ladder logic programming. Thank you and have a good day, my friends. Goodbye.